All right, so this is activity 3.3, I believe. And we are going to be testing some food substances. So we have to set up our teacher demo. And that will be using album egg powder. And so typically I have ordered it so it comes like single use and we just have to put the water in it. So that's what I've done there, and it's like 100 milligrams of distilled water. And then other prep is take a little bit of rice, put it in the bottom of a beaker, add some distilled water to it, and then we'll be using the liquid that ends up boiling. I have here, hopefully not to burn myself, butter melting, and we'll be using that to test. That's one of the food substances. These two are food substances that we'll be using with the kids.
The rice and the butter are food substances?
Yeah, with
Okay.
the kids. And then I'm gonna crack an egg white here or separate the egg out. I don't want my butter to explode here, so let me get that off real quick. I know, very technical gear here I have. Okay. All right, so we gotta separate our egg. We want just the egg white. Fairly easy to do.
Nice work.
I made a mess, but
That's okay.
it's cleaned up. I'll just do this.
And there's our egg white right there.
Yeah, and then we're supposed
Some
to add
butter.
a little distilled water to that. So I'll just stick some in there. It helps so it doesn't get stuck in the pipette is why they're having us do that. Stir that up a little bit.
Mixy, mixy.
Yeah. I'm not using exact measurements. I've done this for a few years, but all the measurements are in the book. So nice and easy. Just try to clean up after myself. So we've got our butter melted. We have our egg whites ready to go. Our rice, we are supposed to boil for about 5 minutes.
Okay.
So that's working. And so let me separate some things
And-
out here.
The purpose of this lab is again?
To determine what's food and what's not food.
Okay.
And so in the end, we end up comparing these food items that we test with the kids, the
Mhm.
egg, the butter, the rice, I'm missing something, milk, something else I'm supposed to use. They compare it with water. Water's gonna end up testing negative for everything, whereas all of this will test for those. Okay. Well, this is the beginning stuff, so.
We have our rice cooking in here. Our melted butter. And our egg white mixed with distilled water.
Okay, why don't you pause it for a minute?
And we have milk in here.
Okay. Starch indicator is something we're gonna use for our teacher demo here. So I'll put a little in there so that I don't contaminate the whole thing. I'm gonna do the same thing with our glucose solution, so I don't contaminate the entire container. All right, and then I gotta get a hot water bath going too. So usually I just have a big beaker. Okay, back up a little bit, cause I'm gonna put this cold thing on this hot thing here. And I was afraid I'm gonna break something. We're gonna be using these little centrifuge things, so we fill them with drops of our solutions or our foods, and then we'll put a couple of drops of the indicators in there. And so we'll talk about the indicators in a moment. Let me get this poured. Oil is another part of the teacher demo.
Is that vegetable oil?
Yeah.
Okay.
Sorry, what I got here. Okay, so while some things are heating up, what's our hot pad at?
Number, it's set on 5.
Okay.
Would you like me to turn it up?
No. All right. Let me go. You can pause it if you want.
Okay.
You go forever. Okay. Activity 3.3, investigation. Can we prove a substance is a food? So what we'll be doing today is testing some common food substances and water to see if they have glucose or sugar in them, starch, fat, and protein. And so the first thing that we want to do is to take a look at some substances that are going to give us an idea of what to look for when we add indicators to our food items that I have. So our first item that we're going to take a look at, if you look at the table down on page 26, it says tube number 1 needs to have glucose in it. And so I am going to take one of these little tubes and I'm going to put some glucose solution in that. And I don't have these in order, but that's okay. So our glucose solution is a clear solution. I've only filled it up just a little ways. It's a clear solution, so when we take a look at our chart or our table that they want us to fill out, we've got color before test, and so we're going to want to put clear in that box. So color from starch test, and what we use for our starch test is iodine. And iodine is kind of a, hold that, got it? Okay. Maybe I can't get this one open. You're gonna have to get this open. Okay, switch. All right, so just as a quick little review, we have glucose. It is clear. We're going to put iodine solution in this. Iodine needs to be kept in a dark bottle so that it retains its properties and does what it's supposed to do. Iodine is kind of a goldish liquid indicator that we will be putting in. And let me put a drop or two in here. And you can, I try not to touch the dropper to the vial here. And there is no change. When we take a look at iodine in a solution, if it contains starch, we're gonna see that change right away. And so for our glucose, it's still yellow. There was no change to it, so there's no starch in our glucose. All right, that's test number 1 for our glucose solution. So let me put our lid back on here. It's a very good practice to follow that. Next, we're going to test our glucose for sugar or glucose. Okay, so when we put this in here, once again, we are working with a clear liquid. That should not change. It's the same stuff. And I have here Benedict's solution that we're going to add. Benedict's solution is a blue colored solution. It's going to indicate if there's sugar or glucose in an item. So we're going to take the lid off. I don't set the lid down. It's a good practice so it doesn't become contaminated. Couple drops of the blue solution in there. And then we will close up our bottle, close our vial up. Now, to test for Benedict's solution or to get the Benedict's to work, we have to put it in a hot water bath. So I have a hot plate set up with a beaker of water that has been warming. And we're gonna put that in here for a few moments and see if anything changes. So if we watch that, we may see a change in it. And we don't ever want to fill our vial too full when we're heating it, and because what will happen is that liquid could cause pressure in there and it could pop open and it could splatter on us, and it might hurt. So I'm just gonna, yeah, we're getting warm enough, so we leave that in there a little bit longer. See what happens. So I don't know if you can start seeing it. We don't really have a blue color there anymore. It's kind of turning greenish. We are getting, you can see that it's becoming green. So we'll leave that in there a little bit longer. See what we might end up with. Okay, and you can see now we're getting more of a yellowish color, almost turning towards an orange. So here, now we're more orange in this than we were when we first started. All right, so I'm gonna take this out and carefully, because it's hot, and hope that stays shut. And you can see that we've got kind of an orangish color going on there. All right, so we need to test our glucose solution for protein. And we have a burette solution that we're going to be using. So once again, glucose is clear, that has not changed. Our burette is a lighter color blue. You can see it's different from the Benedict's, okay? And we'll get this in here. A couple drops of this. And doesn't stay very blue, okay? So let me get a white sheet here. And so you can kind of see that it has cleared up quite a bit. Burette, what's going to happen is it should turn purple if it has protein in it. And so this one did not.
So there's no protein in that.
Right. So that's still clear, or you could say it's light blue.
So if it's yellow or orange, that's a sign of protein.
Yeah.
So we have glucose. With the starch test, we have protein. That's the yellow. Then we did the test with Benedict's solution. It turned an orange color, which shows protein.
No, this was Benedict's, which shows sugar.
Excuse me, sugar.
Okay.
So yellow is protein. Okay.
Okay, so there's no protein in our glucose solution.
Then there's no protein in the glucose.
All right, so glucose solution, clear, okay? We're gonna put Sudan, solution in this. This, I'm really careful with this because it will stain, okay? And it's a really bright color to start with, or kind of a deep, deep red. And, so this is the hardest one to kind of tell if it has changed. And so essentially, it's the same color, it's just a little bit lighter because it's been diluted a little bit. And diluted might be a word that you heard last year, where you kind of water something down or thin something down. So this is still red. And so this is not going to indicate that there's fat in our glucose solution, okay?
So that's like a dull maroon color?
Yeah,
Okay.
yep. All right, so to just recap real quickly, in our data table for glucose, color before the test is clear, so you should have clear written in there. Color from the starch test, it is still yellow, it's still gold, it has not changed a color. Here, I can give us a little bit of a reference point here, so we can see the colors a little bit better, okay? And so our Benedict solution, which is for sugar or glucose, has turned orange, which means there is sugar in our glucose solution, which is a great thing to find out because it came as a glucose solution.
And I'm sorry, this first one turned yellow, what does that indicate? Protein?
This is starch.
Excuse me, starch, okay.
So it's iodine solution, it's still yellow, which means there is no starch
No starch.
in our glucose solution. There is sugar. The Burette solution, it just lightened in color, so there is no protein in our glucose solution. And then our Sudan, there is no fat because it didn't change. It'll change to a really bright red. We'll notice those colors as we get to something that has fat in it.